All right, hello everybody. Thanks for coming up, and thanks for the faculty to organize this salon. I'm a physical geographer. You'll notice that I pretty much speak a different language compared to you guys. So I might not have enough time to finish everything. So if there's something that I could not sort of explain sufficiently, you're welcome to contact me later on. So I'll give you a full picture of my research. I joined the geography in August 2022. Unfortunately, I still have not fully established a research program here in Hong Kong U. Therefore, I choose to share with you my research in the States, where I study including my PhD study for almost 20 years. Focused on sustainable management of arid and semi-arid ecosystem in southwestern U.S. So one of the key research areas is about the process of we call woody plant encroachment, right? It's a process where the original grassland has been displaced by woody plants. What do we mean by woody plants? Woody plants are generally shrubs or trees. It depends on the location. Some of the location you might have shrubs. Some of the location maybe the woody plants can be grown enough to trees, right? That happens widely in the US and in Africa and many part of China as well. So we have, in the past 20 years, we do have improved understanding of this process, right? Previously, we called woody plant invasion, which turns out is not a scientifically correct terminology to describe that process, because those woody plants can be native, it can be from outside as well. It does not have to be from out of the world. For example, for the case in U.S., it does not have to be from within the U.S. It can be from outside the U.S. as well. Which one goes? Okay, here. And as I said, this process happened really globally. There's a nice summary of where you can find that kind of process across the world. As you can tell, this area, North America, has been well studied. If you quickly jump to China, it happens quite often, it happens quite broadly, but it has not been well studied, right, relatively. So that really gives me some opportunity to do research in northern and western part of China. Actually, I have already established some kind of collaboration with mainland universities and institutions to conduct research in Inner Mongolia. Actually, my PhD student is already starting her dissertation on we call desert oases in Inner Mongolia. And as I said, the woody plant encroachment process has been well studied in the US. That happened in a variety of different locations. If you know the geography of US, happened in Huang Desert, Solara Desert, Rocky Mountains, and some of the sagebrush steppe, which is in the central part of central and the west, and then the Green Plains, of course, that's going to be relative central and central Green Plains as well. So it's pretty much across the east side, other than the east side of U.S. And that process, another thing that I want to share is that happened particularly rapidly after the European began to settle in the western U.S., which is primarily after 1850s, right? So keep that in mind. There's a sort of big context in terms of how to explain that process of woody plant encroachment. And the biophysical consequences, some of them are well studied. Some of them are my own research focus, right? For example, there's land degradation process, there are resource spatial heterogeneity, and there is some loss of ecological value, right? And then there is loss of carbon, nitrogen, soil nutrients, and the wind and water processes as well. So those are all the processes that would have changed if you have a woody plant encroachment process. And then we do have something that are uncertain, right? If you study the global picture, you'll notice that some locations that happen in this way, some other locations that happen in a different way. So that include carbon pools, which is quite a big deal, relevant to global climate change and global warming. And we have some ecological aspects of this research. For example, we call it ANP, that's above ground net primary production, which is related to mean annual precipitation, MAP. And then the third one, which is another hot topic, is related to biodiversity, which is also not certain, right? There's some stage you might end up with decreased biodiversity, some stage you might end up with increased biodiversity. And the fourth one is also highly critical, which is groundwater, or water resource. And that would include the depth of water table, relevant to the distribution and the root system of these plants related to the distribution of groundwater. And some of the well-established drivers, which used to be the focus of this study, but as I said, in the past 20 years, those drivers are well-established. That include climate, global warming, overgrazing. That's really relevant to the time when the Europeans began to settle in the Southwest since 1850s. Increasing atmospheric CO2, this is a little bit technical. You end up with high CO2 that would benefit the grasses versus shrubs differently, right? We have so-called C3 shrubs versus C4 grasses in terms of their photosynthesis process. If you have high CO2 in the atmosphere, that could benefit shrubs more than grasses, right? So that therefore the shrubs will gain competitiveness compared to the C4 grasses. And then the large-scale fire suppression could also play an important role in terms of how they affect grasses versus shrubs separately. And I'm going to move on to these are the processes that I particularly studied in particular the top two, right? Those are primary intergenic feedback processes, right? We call it intergenic because it happened internally, right? Exogenic means it happens externally. And for example, the fire vegetation feedback process and the erosion vegetation feedback process, and also you could combine fire, erosion, and vegetation that integrate feedback process as well. And then the last two are considered to be relatively minor in terms of the feedback processes. They work in a kind of small magnitude, small degree. For example, the mammal vegetation feedback process, the vegetation microclimate feedback processes, they also work locally to change the competition between grasses and shrubs. And quickly, the study site that I have focused on in the past 20 years those both were located in New Mexico, the state of New Mexico. This is where it is located in southwestern U.S. The two primary study sites, one is in the south, we call Jornada. Another one is in the north, we call Civieta. And these two sites are 300 kilometers apart. They're both pretty dry ecosystem in terms of their annual precipitation. In terms of their PET represent a potential evapotranspiration. This is how strong the sun is going to be, right? How much water is going to be evaporated from the ground. And then elevation, the study area, and so on. So I'll just show you what the area looks like in terms of the degree and then the magnitude of woody shrub encroachment, right? This is in the southern side. This is what it looks like today. This is what originally, there's still spotty locations where the grasses are pretty high quality, pretty dense. This is the majority of the areas, what the majority of the areas looks like. And then the northern side is going to be slightly different. The degree of encroachment is going to be less, and then there's still no shrub duneland has not been formed yet, right? We could put a question mark over there in the future. And the first sort of framework that we came out, or conceptual model that we came out, is focused on the process of wind and water erosion process, and how the wind and water erosion process could affect the continued involvement of woody plant encroachment, right? We have this different erosion, different woody plant encroachment stage, And then we have increased soil erosion, which I identified. I'm not showing the results over there. The wind is actually more dominant compared to water in that environment. And then, of course, you have the change of nutrients that could also further reinforce the loss of vegetation. So we end up with this so-called conception model that was recently published in 2022 paper. And then more recently, we got a National Science Foundation grant, and we studied the relationship between fire and vegetation feedback process. There's a lot of technical details involved. I'm not going to really go to those technical details. What we did was we used rare earth elements as tracers to identify how these sediments move on the ground and where they move to, right? The pathway of movement between grass, shrub, and there's nothing, we call it bare, right? So if there's, the area has no grass, has no shrub, and then we call it bare. So our experiment just studied how these soil sediment move between these different, we call microsites, okay? And also we did airborne particle measurement to see where this sediment comes from in terms of wind erosion process. And quickly, most of the wind erosion particles come out of the bare interspace, which is quite intuitive. And then the second would be grass, very minimum comes out of shrub. And then in terms of the relative movement, we came up with the pathways, right? Primarily, they move from bare into grass, bare into shrub, and there's very little movement between shrub and grass, between grass and shrub, and so on. And this is the first sort of year of results. Then we have our fire-affected area. We did same kind of analysis, same kind of sampling. We come up with a very different picture of where the particles come from, right? Grass, shrub, and bare, right? Relatively even. And also the pathway of this particle movement is going to be quite different as well. I'm going to show you another result after this. And this is our sort of pathway and sources picture. And this is the before the fire event. And we actually modified this. This is actually more like our original kind of hypothesis. After the results, we actually modified this thing. And we end up with sort of get rid of that source, because that's going to be almost less than 1%. And we also got rid of the movement between shrub to bare, because we did not detect that kind of pathway. And the movement from grass to bare is also being be excluded, and the movement between grass and shrub, grass to shrub and shrub to grass, both of them are being eliminated, because we did not detect that kind of pathway of particle movement. And now for the burned, we do sort of similar kind of analysis. We come with different kind of sources. We come with different kind of pathways as well. And we actually change this from solid to dash, means that goes from primary to secondary in terms of the source of the airborne particles. And we also remove some of the pathways to correctly reflect what happens after the fire event. And this is by a comparison of our control experiment versus the treatment, we call after we burn it. That's our treatment. So we can tell the source difference. We can tell the pathway difference in terms of how these particles move around. Well, this is a last actual study of what I'm going to talk about today. This is a modeling study, right, where we integrate the processes of fire, the processes of grazing, and erosion. So in that way, we have to use a model to do it, because this is a long-term experiment. Those processes will not have a substantial results after only a few years, right? Which primarily is going to be the focus of experimental study. So we use this silent automata modeling approach to investigate the relationship between erosion, fire, and grazing, how they interact over a 300 years of period of time, and for both the Siviata in the north and Jornada in the south. The key message here we have is that we have at Siviata, overgrazing without fire shift the desert grassland to shrubland after 100 years, right? And fire and decreased grazing may reverse, pay attention to that keyword I used here, may reverse the woody plant encroachment, which is really the key, which is really something that we were looking for, right? We want to achieve the sustainable management of those ecosystems, and more ideally, we want to reverse that kind of woody plant encroachment scenario back into its original grassland ecosystem. So if we could do that, that would be really ideal. And shrub dominance is not going to be reversible at Jornada. That's really what we come out from our modeling study. And the conception model that we came out with, the fire vegetation feedback is like this, right? We have our grassland, then we have the fire suppression, then come out with the dominance of shrubs, and then if we end up with fire, then these shrubs will be killed. And then you could end up with benefit the grasses, and then later on with the right magnitude, right frequency of fire, we could end up with the reverse of this shrubland back into grassland. This is what we came up with the conceptual model. And lastly, this is really a summary of what we have in the area in terms of how we achieve the sustainable management of woody plant encroachment, and also the grassland ecosystem in southwestern U.S. And again, we have so-called four dimensions. We have two types of ecosystem represented by Jornada, which represents the highest degree of woody plant encroachment, all the way to the duneland, right? There's very little grass that been found. And the second scenario would be this Siviata, which represent a lower degree of woody plant encroachment. And then we have corresponding management measures, right? If it goes to that kind of stage, then we said that's going to be irreversible unless direct removal of these woody plants using mechanical measures, which turns out is not practical, right? If you want to do large scale of management, those mechanical removal is not going to be economical, it's not going to be really practical. And then sort of in the middle, we could have the reversible process by managing the erosion process, primarily managing wind erosion process. This is, again, our conclusion. And then back to the earlier stage of woody plant encroachment, that's going to be highly reversible by using the combination of fire and grazing, right? That measure would now we achieve the reversed sort of woody plant encroachment process. So that would be the sort of the key message that I have for my research in the U.S. Now, lastly, I do want to talk about this. You guys may be wondering now that research in the U.S., how would you sort of transfer your research in the U.S. to China, right? To Asia primarily. And I think this is highly transversable. There is woody plant encroachment, there is land degradation, there is desertification process in China, in Mongolia, in Central Asia. And so the knowledge, the management practice that I gained out of my research in the U.S. Can be transferable, right? Well, you cannot 100%, but there is technology, there is ideas that can be applied to the ecosystem issues in this area, right? As I said, I already started collaboration with mainland institutions. We study desert oases in Inner Mongolia in a way that desert oases represent the focus of interaction between nature and a human being, right? So I really want to focus my research in that area here in Hong Kong U, right? Let's see how it goes. Okay, thank you.